This figure that you see down here shows the number of motor vehicle registrations, F of T, in millions in the world, with T in years since 1960. Using units, interpret the value of F of 40, F prime of 40, F inverse of 750, and F inverse prime of 750. F of 40. Okay, it's kind of small. The horizontal axis, that says years. This says registrations in millions. F of 40 means we're talking 40 years after 1960. The independent variable for F is T, time since 1960. So F of 40 must be the number of registrations in the year 2000. 40 years after 1960. There's the year 2000. It looks like if you go up to the graph, the number of vehicles is close to 800 million. There's an 800 there if you can't quite see it. A little less than 800 million. F prime of 40 is the rate of change of the vehicle registrations with respect to time. Its number of vehicle registrations is a function of time. The derivative of that in Leibniz notation would be dv dt. That's F prime of t. We've done problems like this before, but now we are also going to be talking about the inverse function. So that's a rate of change of the vehicle registrations with respect to time. It is the slope of the graph at 40, corresponding to the year 2000. You'd want to draw a line segment there. That's a tangent line at this point. Try to estimate its slope as rise over run. Can I do that? Rise looks like it's in the ballpark of 100 million vehicles. Number of years is 5 years, it looks like. F prime of 40 is approximately 100 million vehicles per 5 years is what I was looking at when I was moving the cursor here. I'm not telling you exactly what I was thinking in my head. I was looking at rise over run in doing that. 20 million vehicles per year. That's a rate of change of the vehicle registrations with respect to time. 20 million vehicles per year. It's about how many extra vehicles are being registered every year at that time. The slope is not constant. It starts going up pretty rapidly around the year 2005. The main point of this problem being in this section is we also want to interpret this value of the inverse function and its derivative. With the inverse function, since the variables mean something, you do not want to swap them. You want to take this equation and solve for t as a function of v and write it this way. Now, there's no equation given here, so I can't literally do that. I'm only imagining doing it. Imagining that I've got some equation there, f of t, equal to v, and I can solve for t. The graph is a one-to-one function, so theoretically you can do that. So to answer this question, the 750 must be a value of v, a number of vehicle registrations. And the value of the function must be a time. This function is going to represent the time in years since 1960 when there were 750 million vehicles. In this graph, you don't want to do any reflecting. You want to just change what axis is the independent variable. You'd want to make the vertical axis be the independent variable, go up to 750, then go over to the time it's close to the year 2000. If I had to estimate it most accurately, I'd say maybe the year 1999 or 98 or something. Finally, f inverse prime of 750, we're taking the derivative of the inverse function. We're really finding dt dv. That's f inverse prime of v. It's a rate of change of time with respect to vehicle registrations. Who would ever do such a thing? Isn't time the natural independent variable? Yeah, in the real life application it is, but mathematically speaking, we can certainly do it. We can think of vehicle registrations being independent and time being dependent. Yes, strange, but true. How would I find it? And what would its units be? I'd have to look for, again, the registrations being 750, go over to the graph, make a tangent line, estimate that slope in the opposite direction as a run over rise. Calculate delta t over delta v. you should get the reciprocal of this number, pretty close at least. Wasn't in the exact same spot in the graph, but pretty close. You should get 1/20 years per million vehicle. What does this mean? It means when there were 750 million vehicles registered, the rate of change, these are all supposed to be approximately equal to each other. The rate of change, the derivative, is about 1/20th of a year per million vehicle. What does that mean? It means it takes about 1/20th of a year. What would that be? 18 days or so? For another million vehicles to be registered. That's what it means. About 18 days per million vehicles. So there's an example of an application where you got to think about graphs and you got to think about ideas conceptually, including with an inverse function, as another type of problem you might encounter in the homework due Friday.